Chemistry starts to feel confusing the moment numbers enter the room, especially with something called the mole. The name alone sounds like it belongs in biology or on your skin, not in calculations. But the idea behind it is actually simple once you stop overcomplicating it. A mole is just a way of counting particles. Not small counting, like 1, 2, 3. Huge counting. 1 mole means a fixed number of particles, which is 6.02 times 10 to the power of 23. You do not need to memorize that number to survive this topic. What matters is this. A mole is just a standard amount, like a dozen means 12. When chemists write equations, they are not just showing what reacts with what. They are also showing the exact ratio in which substances react. Those big numbers in front of chemical formulas are not decoration. They tell you how many moles of each substance are involved. For example, when magnesium reacts with hydrochloric acid, the balanced equation shows that 1 mole of magnesium reacts with 2 moles of hydrochloric acid. This means the ratio is always 1 to 2. It does not matter if you are using small amounts or huge amounts. The ratio never changes. This is one of the most important ideas in chemistry. Reactions follow fixed ratios. They are not flexible. You cannot randomly change the amounts and expect the reaction to behave the same way. Inside each chemical formula, there are also small numbers. These show how many atoms of each element are in 1 unit of that substance. So the equation tells you both the structure of substances and how much of each is involved. Now let's connect this to something useful. If you know how many moles of one substance you have, you can use the ratio in the equation to find the moles of another substance. Imagine methane burning in oxygen. The equation shows that 1 mole of methane produces 2 moles of water. So if you have 2 moles of methane, you will get 4 moles of water. You just follow the ratio, nothing fancy. If the ratio is not 1 to 1, you adjust accordingly. For example, if 2 moles of magnesium react with 1 mole of oxygen, then 3 moles of magnesium will react with 1.5 moles of oxygen. You scale the ratio up or down. At this point, you need one key equation that you will use again and again. Number of moles equals mass divided by relative formula mass. This is the bridge between real measured mass and the mole world. So if you know the mass of a substance, you can find how many moles it contains. And once you have moles, you can use the equation ratio to find anything else. Now things get more interesting. Sometimes you are not given the equation directly. Instead, you are given masses of substances and asked to figure out the balanced equation yourself. This is where many students panic for no good reason. The method is always the same. First, you convert all given masses into moles. You do this by dividing each mass by its relative formula mass. Now you have numbers that represent how many moles of each substance were involved. Next, you compare these mole values. You divide all of them by the smallest number. This gives you a ratio. Sometimes you get nice whole numbers. If not, you multiply everything by the same number until you do. Then you use these numbers as the coefficients in your balanced equation. This method is mechanical. It is not about guessing. If you follow the steps carefully, you will get the correct answer. Now let's talk about something that actually controls how much product you get in a reaction. This is the idea of limiting reactants. In most reactions, one substance runs out first. When that happens, the reaction stops. It does not matter if you still have plenty of the other substance left. The reaction cannot continue. The substance that runs out first is called the limiting reactant. It limits how much product can form. The other substances are in excess. They are extra. They are not fully used. Think of making sandwiches. If you have 10 slices of bread but only 3 slices of cheese, you can only make 3 sandwiches. The cheese is the limiting factor. The bread is in excess. The same idea applies in chemistry. The amount of product formed depends entirely on the limiting reactant. If you double the amount of the limiting reactant, you double the amount of product. If you halve it, the product also halves. This is a direct relationship. This idea becomes very powerful when you do calculations. If you know the mass of the limiting reactant and the balanced equation, you can calculate exactly how much product will form. The steps are always the same. First, write the balanced equation. Then calculate the relative formula mass of the substances you care about. Next, convert the given mass into moles. Then use the ratio from the equation to find the moles of the product. Finally, convert moles back into mass. Yes, it sounds like a lot of steps, but it is the same pattern every time. Once your brain gets used to it, it becomes automatic. You can also work backwards. If you know how much product you want, you can calculate how much reactant you need. This is just the same method in reverse. This is not just for exams. This is how real experiments are planned. You do not want to waste materials, so you calculate the exact amounts needed. Now let's test if this actually made it into your brain or just passed through politely. Question: what do the large numbers in front of chemical formulas in an equation represent? They show the ratio of moles of each substance in the reaction. Question: what does a mole represent in chemistry? A fixed amount of particles equal to 6.02 times 10 to the power of 23. Question: what equation links mass, moles, and relative formula mass? Number of moles equals mass divided by relative formula mass. Question: if 1 mole of methane produces 2 moles of water, How many moles of water form from 3 moles of methane? 6 moles of water.
Question. If 2 moles of magnesium react with 1 mole of oxygen, how many moles of oxygen react with 4 moles of magnesium?
2 moles of oxygen. Question. What is the first step when finding a balanced equation from reacting masses? Convert all masses into moles. Question. Why do you divide by the smallest number of moles when finding ratios? To get the simplest ratio between substances. Question. What is a limiting reactant? The reactant that is completely used up and stops the reaction. Question. What happens to the amount of product if the limiting reactant is doubled? The amount of product also doubles. In a reaction, one reactant is left over at the end. What is it called? It is in excess. Question. What determines the maximum amount of product formed in a reaction? The amount of the limiting reactant. Question. What are the main steps to calculate the mass of a product? Convert mass to moles, use the ratio from the equation, then convert moles back to mass.